Hey guys, I just want to go over a quick example of a solution stoichiometry problem with you. I've given you an example reaction here. This is HCl, hydrochloric acid, plus lead nitrate, both aqueous, react to form lead chloride, which is a solid, and HNO3, which is aqueous. Okay. First step in any of these problems is to balance the equation. I already got a little start on it. But balancing the equation just means putting the coefficients in so that the numbers of molecules of each are the same on either side. If you need a review on balancing equations, I'll post another video on balancing equations in a bit. I just want to get through stoichiometry for people who need a little extra help with just that. So let's go through. Let's say you have HCl. We'll start with that. Imagine you had a 0.5 molar solution of HCl. Okay, so what that is equivalent to is saying that you have 0.5 moles of HCl in every liter of that solution. So if you went and poured out a liter of that solution and added it into a beaker or a bottle or whatever, it would have 0.5 moles of the HCl in that container. And that's it. Okay, so what if we had, let's say, 100 milliliters of that 0.5 molar HCl? Okay, now I know how many moles are in a liter, but how many moles are in 100 milliliters? First step to this is to convert that into a liter. Now there are 1,000 milliliters in 1 liter, so you use this conversion factor so that milliliters cancels out, and you get 0.100 liters. Some people are able to do that in their head without doing the math. Other people need to work it out like this. Some people need to do it another way. Whatever way you're good at converting units is fine. Okay, so we have 0.100 liters. Now if we look up here, we know that each liter has 0.5 moles. We can use that as a multiplication factor. So we know that 1 liter of this has half a mole. When we math that out, we figure out that 0.1 liters has 0.05 moles of HCl. Okay, so 0.05 moles of HCl is how much this reaction is starting with. All right, the next step in this process is to use your mole ratios. So that comes up to your coefficients from the equation after you balanced it. So you notice your coefficient of HCl is 2. Okay, let's imagine we're trying to find out how much PbCl we're going to form. Because this is the precipitate, this is the solid in this reaction. That's what's going to fall out of solution, be easy to separate and filter off and weigh. So let's say we're going to figure out how much of this should be formed. All right, so we're going to take our coefficients. Now HCl, 2 moles of HCl, is going to go on the bottom of this conversion factor because it's what we're trying to get rid of. What we're trying to get rid of always goes on the bottom so we can cancel it out. On the top you're going to put what you're trying to form, which is your PbCl2. Now we get 1 mole of that every time this reaction runs. So that's your mole ratio. You can cancel out the moles of HCl, and that leaves us with moles of PbCl2. So that means we need to divide this by 2, which means we get a 0.025 moles of lead chloride. All right, so we're going to turn that into grams of lead chloride. Now to do that, we're going to need the molar mass of lead chloride. So the molar mass of lead chloride you find from the molecular weight of each one, or the molar mass of each of these on the periodic table. So your atomic mass, you can go look those up. Lead, if you look it up, is 207.2. Chlorine is 35.5. So let's add that up. 207.2 plus 35.5 twice. Okay, if we add all that up, that's 71 plus 207.2 is going to give us 278.2 grams per mole. So that's your PbCl2. Now we'll come down here, 0.25 moles of PbCl2 times 278.2 grams and 1 mole of PbCl2. So we can cancel moles out right here and just plug this math into a calculator real quick. You're going to multiply 278.2 times 0.25. So 278.2 times 0.25 gets us 69.55 grams of PbCl2. Okay, so that's how you work through one of these problems. It's actually really similar to a regular stoichiometry problem. The only difference is that first step where you, instead of converting the grams of your reactant into moles, you convert the milliliters of your solution into moles of a reactant instead.